Hello everyone, welcome back to my first video of Math Made Easy. So before we get started, let me tell you a little bit more about how we're gonna do things here. So there will be three different types of videos. Number one will be the short form videos where I just explain a subtopic of a chapter to make it easier for you to understand and so that you don't have to watch an entire video to understand just that one part of the chapter. The second thing I'm going to do is consolidate all these short form videos into a long form video so that you can watch and understand the chapter in one simple video. Third, I am going to upload videos on application and solving questions so that you know how to apply the knowledge that you have learned in your schools or in my videos as well. So without further ado, let's begin the first topic of the Sec 3 emath syllabus, quadratic and fractional equations. In this video, we'll be talking about completing the square. So let's begin. Teach you how to solve quadratic equations in one variable by completing the square. So without further ado, let's begin with a recap. So if you guys do not want a recap, you can head on to this timestamp over here. So in the recap, I'll cover three things: the zero product rule, solving quadratic equations by factorization, and solving quadratic equations in the form x plus r squared equals to s. You do not have to worry about the s or the r, just focus on this term getting squared to give you another term. So let's begin. For the zero product rule, all you need to know is that when I take a times b and it gives you 0, that means either a is 0 or b is 0. For factorization, there are two methods of solving it. A, you have this cross method, where you write the terms here and then you cross multiply or whatever. Now, I want you to transition from that into this common method here. You may have learnt it in Sec 2, but this is one of the more easier ways to understand it. I call it the tic-tac-toe method. First, you draw a tic-tac-toe table with 9 squares. So these squares are going to be your terms basically. So from your equation, let's say x squared minus 7x minus 8 equals to 0, it'll give you something like x plus or minus what times x plus or minus what equals to 0. So these are gonna be these answers. So this way of doing it helps you understand how to complete the square better. So let's do that. Number one, as you may know, we write the x squared here and the negative 8 here. Then x squared, we break it into x multiplied by x, which is basically x times x. So this is multiply when you bring them together. X times x times x equals to x squared. So, and we write the negative 8 here. From there, we want to get a negative 7x. And how do I get negative 7x? Which means these two boxes must equal to negative 7x. So how do we get that? Well, we break 8 into its multiples. Its factors, which includes 1 times 8 or 2 times 4. And since we know to get 7x, we have to use 1 times 8, we can write it such that we put 1 here and negative 8 here. Why negative 8? Because we have a negative 7 here, which means the bigger number must be a negative number. After doing this, we know that these two terms add up to negative 7x and we can write the respective terms on top here. Oh, sorry. Remember, when we write it across the board, we need to multiply it by the x. So let's do that right now. X and x. You can either write x or 1x, up to you, but usually we'll write x. So this will give you 8. And ta-da! There are your terms. X plus 1, x minus 8. Plus 1, x minus 8. Yep. And now on to to me, the most simplest way of solving a quadratic equation. X plus r equals to s. So let me give you an example. Let's say I give you this expression, x plus 3 squared equals to 14. How you solve it? Are you going to expand x plus 3 into x plus 6, x plus 9, then bring the 14 over and minus it from 9 and then solve the factorization? Or can you just bring the square root over? So just bring the square root over. So you get x plus 3, and once you bring this over, you get square root 14. But now what most of you may get penalized for is the lack of this term. Now, to cover a little bit, when we take square root 14, we are thinking 14 is a product of two of the same number. So let's say triangle and a triangle, two of the same terms. So these two terms can either be positive or negative, because when you multiply two negative numbers, you get a positive number. So we need to account for both scenarios as well. That's why we have the plus or minus square root 14 there. Now, when you take x plus 3 equals to plus minus 14, is that everything else? No, you still have this 3 here. You just bring the 3 over. So you get not plus, but for your understanding, minus 3, or x equals to negative 14 minus 3. This is just for your understanding. You don't have to write the plus symbol here. And there is your answer. You can either leave it in this form, or you can change it back to decimal place, where you type in square root 14 in your calculator to get about I don't know, you just type it in and you'll find out. And there it is. There's our recap. So now let's get back to completing the square. If you look on the bottom right of the screen, you'll see this expression here, x plus r squared. Now this is what we call a perfect square. What's a perfect square, you ask? Well, you may know of squares like 16 and 9 or 25, which will give you 4 squared, 3 squared, and 5 squared, which basically means to say a perfect square is any number that can be expressed in a form of a square of an integer, which means to say if I give you 1.3333 squared and whatever answer that gives me, that is not a perfect square. It's not a perfect square. So you should all understand that, which means to say this can also be applied to expressions as well, which means x plus 3, this is a number. It may or may not be an integer, we don't know that, but we can assume it's a number, it's a value. Well, if we say this number or this term squared, then this is also a perfect square. Now, when viewed pictorially, a perfect square is like a square. Let me draw it out for you. Square. That's not a square. A square. Yes. No, that's not a square. Okay, that's a square. Now, a perfect square is what you say. A value here, a value x times a value y will give you the area of this square exactly, without anything that you need more of or you have excess of, which basically means you get the area of the square exactly, which means to say, let's give an example. X plus 3 squared would give you x squared plus 6x plus 9. And since this has a square, this is a perfect square as well. A perfect square, which is in the form ax squared plus bx plus a constant c. So this is usually a completed square already, because you are able to deduce from this form back to this form with the squared function. So that is what you have learned in Sec 1 and Sec 2. Now, remember factorization, where we use this multiplication table to help us understand the concept of the square. So let's do the same thing here. Let's say I give you a value, x squared plus 6x. Is this a perfect square? Is this a perfect square? Some of you may know the answer, some may know the answer but not know the explanation behind it. So let's get into that. So if we were to draw it like what we did here pictorially for factorization, the multiplication table, and we draw the tic-tac-toe format. So as I said, all these four corners, this 1, 2, 3, 4, 5 spaces are the outside of the square, while these four boxes are the inside of the square. So the yellow box is the square. The yellow box is the square, the imaginary square we are thinking about. If you're unsure, you may refer to your textbooks or search online to have a more clearer understanding. Now let's say I put the values here. Remember, this is our yellow square. Let me put it yellow as well. These are the values of our square, which we need to put into the square and not outside, as this is the completed part of the completed square form already. So we give x squared here and 6x. But you know 6x goes in here, something x and something x. But these two must equal to 6x. So it can be 1 plus 5, 2 plus 4, 3 plus 3. But we don't know that. So let's say we know this is 6. Let's say it's 3 and 3. But we don't have a c value here. We don't know what this value is. And with that, we cannot complete the square. So without a c function in the equation here, a, b, or c, if we are missing one of these variables, then we will not be able to complete the square. So the aim of completing the square is to get all three values. That is the main aim. Now, how do we change this into a completed square form? Well, obviously you need to add a certain value. But do you know what that value is? Well, let me touch a little bit on that. So take x squared plus 6x for example. and I give you x here, 3 here, and 3 here. Because we know that these two values are equal because it's a square, so they have to be equal. And that's the only possibility we have right here to ensure these two numbers add up to 6. So, what can we do to get this missing number right here? Well, by deduction, we know that this is 3 and this is 3. So when we take 3 times 3, what do we get? You get 6. Well, that's how we complete the square. And other examples in your textbooks will show the proof and more theoretical based understanding for you to understand how you can actually need to add something for you to complete the square. So if you notice that here the answer is 6. Oh wait, sorry, 9, because 3 times 3 is 9. And what is 9? 9 is just 3 squared. Which means the missing number needed to complete the square is another perfect square. And another characteristic of this is that if you see here, 6x is the second term in the ax plus bx equation, right? And 6 divided by 2 would give you 3. Which means the number needed to complete the square is 9, or 3 squared. And what is half the coefficient of the term b, i.e. the b term here? In this case, the b term is 6, so you take half the coefficient of the x term, or b, which is the same thing, by the way. That will give you 6 divided by 2, which is 3. And what is the completed square form? The completed square form is basically this answer, where you get this answer, where you get something squared, an integer, a term, an expression squared. That is a perfect square. And from here we can deduce the completed square form is x plus 3 squared. So you can review a lot of other examples and theories, but here's a basic understanding with one example so that you understand why I am adding a value to complete the square. Which means to say, in order to complete the square, I need to add a value. And what is that value? I need to add half the coefficient of b. I need to add the number needed to complete the square, which is 3 squared. And how do we get 3 squared? Well, if you go read other examples, you realize the number needed to complete the square is always half the coefficient of b, half the coefficient of x, which is b, squared, which means 3 squared. So in essence, that will be b over 2, because half, squared. Simple enough. If you have any more questions, or if you think my explanation is not clear enough, please tell me in the comments below. Thank you. So let me show you an example. Let's take a new term, x squared plus 12x. Obviously, this is not the completed square form. So what do we need to add in order to make this whole square complete, i.e. completing the square? So I said to add b squared, b over 2 squared, right? So let's just do that. This is b divided by 2 is 6. 6. So we get x squared plus 12x plus 6 squared. Remember, this is basically 12 divided by 2 squared, which is what we said earlier. But remember, left hand side must always equal right hand side. And now we have included another 36 here, which means we need to take away another 36, which is the same as 6 squared, to make the expression equal to right hand side and left hand side. And from here, we can see that this is the completed square form of the equation already. So we simplify. We turn this by factorization of your method by the cross method or the multiplication tables method, or by formula, which I will teach you all later. You will get x plus 6 squared. And remember, to make the equation equal, you get minus 36 once you simplify it. And there is your completed square form. And that's it for this video. If you have any questions, any queries, any feedback, any complaints, please leave them down in the comments below. Thank you.